Something new has appeared in our cosmic neighborhood. It arrived without warning, a silent traveler from the deep, dark expanse of space. Astronomers first saw it as a faint smudge, a whisper of light against the infinite black. They named it Swan R2, but this is no ordinary visitor. It is a puzzle, a mystery that has captured the world's attention. Scientists are looking up, their telescopes fixed on this strange new object. They are asking questions. What is it? Where did it come from? And why is it behaving in ways we have never seen before? The world is watching, holding its breath. This celestial wanderer is now hurtling towards our inner solar system. Each night it grows brighter, a ghostly beacon in the twilight sky. People from every corner of the globe are stepping outside, their eyes turned upward. They see its long, ethereal tail stretching across the constellations. It is a breathtaking sight, a beautiful and unsettling spectacle. The scientific community is buzzing with an energy not seen in decades. Phones are ringing at all hours. Emails are flying across continents. The discovery of Swan R2 was almost an accident. It was found not by a giant state-of-the-art observatory, but by an automated system. The Solar and Heliospheric Observatory, a satellite known as SOHO, keeps a constant watch on our Sun. Its SWAN instrument, which stands for Solar Wind Anisotropies, scans the sky for hydrogen. On a routine scan in the late summer of 2025, the instrument detected a massive cloud of it where none should be. This was the first hint. An amateur astronomer, carefully reviewing the publicly available data, was the one who raised the alarm. A new comet had been born into our awareness. A comet, in its simplest form, is a cosmic snowball. It is a clump of ice dust, frozen gases. These objects spend most of their lives in the cold, dark outer reaches, far beyond the orbit of Neptune. But sometimes a gravitational nudge sends one on a long journey towards the Sun. As it gets closer, the Sun's heat begins to warm its surface. The ice turns to gas, creating a glowing atmosphere called a coma. Solar winds then push this gas and dust away, forming the long, beautiful tails that we associate with comets. But Swan R2 immediately seemed different. The initial observations suggested it was enormous. The cloud of hydrogen gas surrounding its nucleus was vast, larger than the Sun itself. The most striking feature of Swan R2 is its tail. Comets have two tails, one made of dust, one made of gas or ion. Swan R2, however, appears to have several. They weave and twist in a complex dance pushed by the solar wind, but it is the size that is truly staggering. Its tail is estimated to stretch over 100 million miles, a length that could easily span the distance from the Earth to the Sun. No comet in recorded history has ever displayed a tail of such magnificent and terrifying proportions. It paints a broad, luminous stroke across our night sky, a celestial brushfire that grows with each passing day. Then there are the colors. Comets typically glow with a greenish-blue hue, the result of diatomic carbon and cyanogen molecules being energized by the Sun's radiation. Swan R2 does glow green, but it also shifts. Observers have reported sudden intense flashes of deep crimson and startling violet. These colors are not supposed to be there. They suggest a chemical composition that is utterly alien to scientists. Even more baffling is its trajectory. Swan R2 is not following the clean, predictable arc of a normal comet. Its path has subtle but definite wobbles and shifts. To understand just how unusual Swan R2 is, we can compare it to another recent and memorable visitor, Comet 2I/Borisov Comet Atlas. Comet Atlas, which graced our skies in 2020, was itself a spectacle at its peak. It was enormous. Its coma stretched nearly 500,000 miles across Halley D as a potential comet of the century, but Swan R2 dwarfs it completely. The nucleus of Atlas was a few miles wide before it disintegrated. Early estimates place Swan R2's solid nucleus at over 60 miles in diameter. A true giant, a behemoth from the interstellar void. Size comparison: Atlas versus Swan R2 versus Earth for scale. The velocity tells another part of the story. Comets speed up as they fall toward the Sun comet Atlas, about 110,000 miles per hour. Hard to comprehend. Swan R2 moving even faster. Preliminary, nearly 200,000 miles per hour. This extreme speed suggests it is not from our Oort cloud like 2I/Borisov, likely interstellar, a messenger from another star system. The mystery of Swan R2 deepens when we realize it is not alone. As astronomers tracked the giant comet, they noticed something else. Trailing it, almost like a shadow, is a second object. It is much smaller, fainter, and designated simply as R2b. This second object is also on a strange, non-gravitational trajectory, seemingly matching the course corrections of its larger companion. The appearance of one interstellar object is a rare event. The appearance of two travelling in tandem is statistically staggering. It is a coincidence of such monumental improbability that most scientists are refusing to call it a coincidence at all. What could this second object be? One theory: a fragment that broke off the main nucleus long ago. This would explain similar paths. However, R2b does not appear to be a simple piece of ice, rock. It does not have a coma or a tail. Spectrographic readings, though faint and difficult to obtain, suggest it is dense metallic. It reflects sunlight in a way that suggests a solid, possibly even polished surface. It is not behaving like a natural fragment. It is behaving like a separate, distinct entity accompanying the larger comet on its journey. The discovery of Swan R2 and its mysterious companion has ignited an unprecedented global scientific response. Observatories from the Atacama Desert in Chile to the mountaintops of Hawaii have ceased all other work. Their powerful lenses are now singularly focused on this one patch of sky. Astronomers are working in shifts around the clock, gathering every photon of light they can. The goal is to build a complete picture of these objects before they swing around the sun and head back out into the deep, leaving us with only questions. Time is of the essence, and the scientific community is united in a frantic race against the clock. Teams of chemists and physicists are analyzing the light signatures, the spectra, with intense focus. They are trying to identify the strange elements causing the comet's crimson flashes and violet flashes. Supercomputers are running complex simulations, attempting to model the comet's bizarre trajectory and the forces that might be guiding it. Every new piece of data is shared instantly on a secure network, allowing researchers across the world to collaborate in real time. This is science at its most dynamic and collaborative, a planetary effort to understand a planetary-level event. As scientists around the world shout their findings from the rooftops of academia, the world's governments remain conspicuously silent. Major space agencies like NASA, ESA, and Roscosmos have issued no public statements. Their social media feeds, usually bustling with updates on missions and discoveries, have posted nothing about Swan R2. This official silence is deafening. In the age of instant information, the absence of it from official sources is a powerful message in itself. It has created an information void that is being filled with public speculation, anxiety, and 1,000 whispered questions online. Why this wall of silence? Perhaps their more powerful classified observation tools have revealed details about Swan R2 and its companion that are being kept from the public. What if the data is not just strange, but alarming? What if the course corrections are not just wobbles, but precise, calculated maneuvers? The world waits, watching the sky and listening to the silence. If you like this content, please subscribe and like our channel, How To Education, for more enlightening content.